infrastructure is not one of the main pillars of SUPERSHINE project. It's an important support for energy savings. It has been proven with a lot of EU projects, Horizon or LIFE projects, that there are significant savings out in urban green infrastructure. So what is it? Urban green infrastructure are designed networks of natural and semi-natural spaces, which can include parks, green corridors, green roofs, community gardens, even facades, green facades, green walls can be included in this definition. They are connected networks of elements, green elements, vegetation, which means vegetation, and water elements as well. So the main objective of urban green infrastructure is to enhance the biodiversity, improve the environmental quality. It can be air quality, water quality, soil quality, and it will also support climate resilience by flood prevention or cooling effects, and it supports human health and well-being. And as you can see, those objectives are not easy to materialize or monetize. So it is a difficult decision for the local governments or private investors to make or to justify the investments in order to get financing support. As we mentioned, the core components can be green roofs, community gardens, urban reforestation, especially if supported by pollination, so that the biodiversity can be more effective. So the functional benefits, side benefits can be said, it's the stormwater management, habitat restoration, being able to reach to green spaces within a shorter period of time, and contribution to the urban ecosystem with the health and carbon reduction benefits. So the phases of the implementation is like a project management, actually. So you plan first, and the plan should also be in line with cities' other objectives as well. So the planning, the feasibility are important for the site selection, especially. You need to take into account the technical aspects of the implementation you are making. So that is very important for the site selection. Then the design and preparation phase. Construction and installation is important because it is not very easy to find skilled workforce in this area, especially in the new and innovative implementation types. For example, green roofs need really concrete water, strengthening the leakage of water, or those kind of different implementations really matter, and poor quality of labor can cause significant damage and increase the investment cost and the maintenance cost, especially. Long-term maintenance and evaluation is also one of the important subjects, because sometimes the maintenance cost in the long run can be more than the investment itself, and it is not an easy task to do because it needs commitment for a long period of time, and otherwise your investment is going to be wasted. Sorry. So in terms of technical, we have already started talking about how we can do it effectively. So in technical terms, it can be really complex, like green roofs, or it can be really easier, depending on the topography or the area. for example, reforestation, if it is suitable. So the site conditions, the existing infrastructure, the needs to integrate to routes. For example, when you are talking about green corridors, you need to take into account the infrastructure around the area. The labor, as I said, you need to have an expertise, and it is not very easy to find. And it is not very technically demanding, urban green infrastructures, but still it needs to be carefully designed and maintained. Initial investment costs are, some of them are higher than the others. A mixed use of all of them can be a solution to decrease the investment costs. As we said, maintenance costs can be significant, and funding sources are usually municipal budgets, but it should also be the private investors, companies, stakeholders, or citizens can also be involved in funding, and it is not very common right now. Securing funding is key to the maintenance of the urban green infrastructures. And in terms of environmental, we can say that the highest score is the environmental score, because it has a lot of environmental benefits. Urban heat island effect decreases, air quality, biodiversity increases, and as we said, these outcomes are not materialized. It is not easy to materialize them. So it also supports climate adaptation and sustainability of the city. And if the stakeholders are involved at an early stage, the acceptance rates are really high. So they also increase environmental awareness of the community around the green infrastructure. Residents' involvement at early stages are we can get better results with the early engagement. So actually, we have talked about almost all of these, but there's also one thing that needs to be taken into account: the legal restrictions and zoning laws.
Sérgio Faia está a descer.
So,
Não, Sérgio Faia, sim.
mute the microphone. Thank you. So recommendations for urban green infrastructure is integrating it to urban planning early, easy. It makes it easier for the city to implement them, so that you can have the best selection of areas to implement the urban green infrastructure. As we said, engaging communities is in early stage is also very important. Sites and stakeholder assessments are key to have a successful implementation, and monitoring performance and adapting to different circumstances is also a key, but this is sometimes the most difficult area in urban green infrastructures. So when we come to what not to do when doing urban green infrastructure, if you think it's as a decorative or something that will not look nice, this is going to, it might not be a good investment, or you can leave out some of the critical issues, you overlook them, and then you have more trouble afterwards trying to fix the damage. Short-term funding will not cover the maintenance for the long term, so it's not safe to do that. And trained maintenance is very important. Otherwise, the vegetation might die. There might be water leakages or these many other problems can occur. And for green roofs is very tricky ones, most tricky ones, and it is likely to be the most expensive one because there are a lot of structural assessments to be made and controls to be done. And also the non-permeable places, materials to be used will increase the especially increase the effectiveness of the flood prevention and similar disasters. So we have observed in many projects that there can be 45% of reduction in stormwater runoff, which can prevent flood, up to 4 degrees Celsius in roof surface temperatures, 13% reduction, around 13% reduction in air pollution, and increase in species diversity. If you support them with the pollinators, that would be even better to have more biodiversity in terms of insects or other green other vegetation. And I think that's it. And now I will give the screen to Anna so that we can ask some questions. If you have gathered any useful information from our presentation, I hope you found it useful. And if you have any questions, I can ask, always answer. Anna, do you want to share the?
Yes, of course. Thank you, Ezra. I will share the link.
Very much.
I will share the link for the chat. Is somebody have problem to add to the interactive game? Please tell me through the chat. I am going to share my screen. I would to check is you can see my screen. Yeah.
Yes. Yes, we can see it.
Thank you. We are start with the first question. The idea is you click the photo, what you consider what is the correct answer. For example, in that case, the first one is the green roof. And if you click, you can pass to the second question. In that case, the correct answer is the second as well, securing sustainable funding for maintenance. So we can continue with the game. The third one is, the third question and the correct answer is the third one, lower local temperature and manage rainwater. And the last question is what factor increased public acceptance of the UGI the most? And in that case, the correct answer is the second as well. Residents activate involving planning and upkeep. So, well done. And we can continue with the workshop.
Maybe if we can ask if anybody who made it correctly, all of the questions correctly, is there anyone who selected the correct ones? All of them. Maybe you can raise your hands. Of course, Isabel. From our consortium, though.
Yes, well done. I did it as well. So just one focus on the one question from the Mir and for Ezra. I saw you okay. It was mainly focused on the environmental part, but we can see there is a lot of planning activities, and so how you think that's we can combine, and maybe we will pass through during these workshops all the main part related to the energy efficiency and to urban planning, so how to involve the local communities and in the same time assure adequate finance resources, and I mean, I know it's pretty hard, and then apply the technical solution. So where's the priority for you?
It's a tricky question. The priority, it depends on the priority of the city, actually. If you want to have decarbonization, fast decarbonization, you might want to increase the green areas, and you might also want to do it around crowded areas. For example, if you have somewhere like a center of the city where there is not much shades or things like that for people to cool down, you might want to have solutions according to that. It really depends on the area that you want to do the implementation and what you are doing it for. Because if you want the buildings to save more energy, then you probably would go with the green roofs and green facades. Everything near the non-permeable surfaces, so that you can cool the areas. Or if you want to prevent floods, then maybe you can increase the number of trees around the rivers or any water areas. So financially, most of the implementation seems to be on governments, local and national governments, but we need to find a way to take other stakeholders in the equation. Otherwise, it is going to be limited. They have limited budgets. For example, Valladolid did something really clever when they were doing the green wall. They ended up having an agreement with a multi-department store, which is a big chain. The maintenance part, they were going to do it. The store took the responsibility to do the maintenance. But the unfortunate thing was that the store moved to another building afterwards. That's a risk, but so the municipality, the city council, just put the first initial investment and then let the store keep the maintenance. So this kind of public-private partnerships might play a key role in deciding what to do, when to do. I don't know if I answered the question.
Of course, okay. There were not well, right answer to the question. It's very open, and we know, and we experience as well, in our activities after 3 years and more. So yeah, so it's a combination of different factors, of course, and you're right. It depends from the needs of the local cases. So and I think it depends also, talking about the technical solution, and now we are going to to listen about that from Kartif and well, instead from Anna. about the presentation and the solutions that Kartik identified. So Anna, the floor is yours.
Thank you, Ricardo. So, yeah.
Perfect. Just make full screen and we are there. Yeah, okay.
Okay. Thank you, Ricardo. Hello, everyone. I'm Anna. I'm joining with my workmate, Julia. Today, we will present to you the envelope insulation topic. I want to share with you some slides about this important topic and intervention in the building facade. Because the work that will be carried out on this element could be improve the energy efficiency and reduce energy consumption as well. To start with this technical webinar, we would like to share some general data about European current energy context, so that everyone understand why improving the building envelope is so important and necessary in those days. According to one paper published in the Computer Environment and Urban System magazine in 2021, almost 40% of European residential buildings will be before 16, and the main part of this building is located in the North and West European part. The European built environment ecosystem is one of the largest energy consumption sector in Europe. And in the same line, in this ecosystem, building account for around 68% of total final European energy use. According to current publication about European Commission official website, in Europe, 85% of buildings were built before 20s, with 75% of them having poor energy performance and decrease the European energy consumption used in buildings. In the same line, 80% of the energy used in Europe home is for heating, cooling, or hot water as well. And according to European Commission publication in 2019, I trying to provide some good news or headlines. And I would like to add that between 2025 and 2023, GHGI emissions from buildings decreased by almost 43%. Bearing in mind all this data, is clear that we need to improve the condition of the old building stock in Europe, focusing on the need to improve energy consumption to achieve the European goal of neutrality for 2050. And one way to achieve is work on improving the building envelope of facade. Indeed, retrofitting the thermal envelope and replacing windows can reduce energy demand between 20 and 30% and get up to around 30% of reduction of energy losses. In fact, is the bearing part of the envelope is not changed, but some elements could be added to change energy building behavior. Now we are going to see some of them. I want to focus the option and the role of passive strategy in one all building facades. These strategies are design solutions that can reduce energy use and improve comfort without using mechanical system or active system as well. The goal of this intervention is to build with envelope, orientation, natural ventilation, and sun lights to reduce the need for heating and cooling. Therefore, using natural condition is one of the key aspects that should be considered when design or implement this kind of solution. For that reason, the localization of the building is one of the most important factors in that case. Considering the importance of these strategies and under the umbrella of the SUPERSHINE replication plan, we was developed to analyze how many degrees, how much temperature, and how much energy consumption decrease can be achieved with this strategy are applied to an existing or old buildings. Now we can start with seeing some of the solution. There are many ways to improve the facade or work with the envelope of one building. Some of the most common ones are the actions that are going to see first. Two solutions that in most cases should be installed together are improving or replacing the journey in one facade and increase insulation in an existing facade as well. Changing windows and door can reduce energy consumption by about 90%. And according to our calculation, in the specific case of the SUPERSHINE project demonstrator, the mass reduction range is between 29 and 37. And the other main action to reduce energy consumption in a building is increase the insulation or use ethic system as well. This can reduce the energy consumption by about 33%. And in the SUPERSHINE case, the values obtained range between 60 and 22%. Now we can continue with the important to improve the insulation in one building. In this picture, you can see the impact of this kind of solution through the thermal photos. We can see a comparison of the same facade. One it is the original state, another where the ETIC system has been installed. By comparing both photos, we can see both the insulation effect and the conductivity and how thermal break are reduced. In the facade with the implementation of ETIC system, thermal break are mainly located on the balcony and in some part of the windows, while in the original states, thermal breaks are present across the entire facade. One of the main barriers to install ETIC system is the difficulty of applying them to heritage or protected building. In this picture, you can see one original building of this style, and we are going to see different rehabilitation approach for these same buildings. This second picture shows a rehabilitation intervention where a traditional basic ETIC system was used with loses the character and element of the heritage character. Sorry. This last picture shows the current state of the building, where never ETIC system, new ever ETIC system has been installed that include and preserve all the heritage element of the facade, maintaining its original character. If you focus in the lower part of the windows, you can even see that the original element had been preserved. Although this element produces thermal breach, which is general and desirable, but the losses produced by this small element don't result in significant energy losses. Continue with the same system. When I speak about envelope retrofitting, we used to think about acting only in the facade, maybe including some extra elements such as driver clothes cover or small balconies, but these interventions are more aesthetical than an energy impact ones. It's important to take account that when retrofitting the envelope of a building, it's also important to renew the roof of the building as well. A facade not insulated produce about 33% of heating losses, and the heating losses through the roof are 25% as well, so it's a very high value. For that reason, roof have to be also into account when speaking about envelope, and it's very important to consider that the deep renovation or in the old building. And this picture try to show a sample of this kind of deep intervention. For the last part of this ethic brief information, one thing that we have to take into account when we want to intervene in an old facade is the possibility that lose of the structural capacity. For that reason, one common solution when you apply ethic system in a building is to include an auto-portant system, or in the other way is create a substructure where it can be installed. Continue with the passive strategy. Another way to intervene in the facade is adding a glaze buffer gallery. This solution can reduce energy consumption by around 50%. And in the SUPERSHINE case study, this action will allow an energy consumption reduction of almost 90 to 33%. In this context, we should explain the use of this element. That is a typical use in Mediterranean architecture. It's called the glaze buffer gallery. You can see in the picture of the slide. This element helps to increase the indoor temperature of a building and heats construction element when exposed to sunlight, promoting the thermal inertia of the facade walls. These elements also allowed sunlight to enter and warm the space. At the same time, the gallery protects the facade from the humidity and allow the wall to retain heat and increase its temperature. It's important to consider that during hot periods, act as a consortium element, improving performance as well. Other system that can be installed in envelope retrofitting system action is a green wall. For the case of green facade, its installation can reduce energy consumption by around 22%. And in the SUPERSHINE case, the value ranges between 11 and 80%. But their benefits are not reduced to the impact of the energy performance. According to one published of University of Birmingham in the 2026 is year in UK, more than 1,100 people died to the poor air quality. In many cities, tall buildings keep pollute air at street level and increasing pollution concentration in the urban environment and affecting the health of the citizen. Green facade and green roof can help reduce these problem or issues. And the previous study showed that the installation of this element in urban area can reduce air particles by up to 60% as well. These type of solution are linked to nature-based solution presented previously by Demir, in that case as well. Other important intervention, especially because of climate change and the increase of the world temperature, is the installation of shading elements. In this case, the design of the solution is very important as there are many different types of structure, material, and way to install them. But this element is not only an aesthetic option, but is really functional ones, because depending on the localization of the building and the placing of this element. One thing to take into account in this installation design is the azimuth and the sun attitude angle. The azimuth is the angle between the north and the perpendicular angle for a window's position. And the solar angle is the angle formed between the sun and the floor projection of the building as well. Finally, with this part of the webinar, I want to continue with a brief speak about a smart facade sensor. This element is not a strictly a passive element or a strategy action. In many cases are installed on the envelope and help improve the energy behavior of the building. The sensor to control energy use and improve comfort for the inhabitant of its building, and can be used to adjust lighting and heating, ventilation, or air conditioning system based on the movement of the occupancy, monitor indoor air quality, and detect as well a water leak, among other things. By providing real-time data, they help reduce energy consumption, lower costs, and improve building performance, while having the user to potentially to know what is happening in their buildings. So to sum up the previous information, I want to add that it's important to found the buildings built before 18, and should be prioritize the retrofitting process in urban area, as in general they have higher energy losses. A reduction of around 90% in energy consumption is obtained when you change the windows and improve the insulation. And interventions are not limited to the ethic system. You can enter with other elements such as green facade, green galleries, or siding elements, among others.
And now I'm taking the floor. This is Julia speaking now. And continuing with this presentation, what I'm going to talk to you about just in a few minutes, it's about some other information that you can find in the materials that we have developed for these capacity building actions, and that will be available on the website along with these presentations and more materials in the coming months, which are some of the aspects related with the use and how to install, and more than how to install, which are the process that we have to follow. It's similar to some of the information that Ezra showed before for this other case. So, yeah, can we go to the next slide, please? Okay, yeah. So I'm going to speak just about a couple of aspects. One of it is which are the implementation phases for this kind of actuations in buildings. So when retrofitting a building, it's quite important to have not only in mind the actuation itself on how to mount it and so on, which is of course really important, but also some preliminary works that have to be done. So an initial analysis have to be done. In many cases, thinking about all buildings, will be needed a building audit, because in many cases there are not enough information of the building itself so as to make a good selection. And afterwards, taking also into account which are the climate conditions, as was mentioned before by Anna, depending on the solution that we are going to apply, it's needed to know the conditions that apply to this specific place. So we have to check this to select the correct materials that have to be installed in this specific location, in this specific building. And of course, we have to check which are the different legal aspects that have to be taken into account in this country, in this city, to comply with them. Next one. So the second phase, of course, would be the construction itself, the installation of the different elements. And this includes the preparation of the facade in case that is needed to put some of those newer basements for the building, for example, the insulation itself, the replacement, and so on. And finally, we don't have to forget this last other phase, which is the monitoring and maintenance phase. In many cases, we need to put in place some different inspection systems. It's maybe needed to have some training both to the users inside of the building, but also to the maintenance staff. And also it's needed a maintenance plan. And all of these will have, together with it, the economic aspects. Yeah, go to the next slide.
Sorry.
Yeah, so last part of this, we wanted to share with you some of the recurrent risks that we have identified with the experience of the project partners in this kind of actuations in refurbishment of old buildings. As you can see, we have divided this into different aspects, different areas. So, for example, in the technical part, one of the main thing is that we have to take into account that, of course, we are retrofitting old buildings, and in some cases, there can be damage. If we made this initial inspection, we can maybe see some damages that were not initially seen, and this can make the work more difficult. Maybe we are going to have to select different aspects or so that were not initially contemplated. We have to also take into account as I was saying before, the climatic conditions of the city where the place where the building is located. And now, even with the time being, we have to have into account things like heat waves or high humidity climates, maybe if the building is in the coastal place. So not all the materials and all the solutions are to be applied in all buildings. So we have to select the more appropriate ones. And something that also Anna mentioned before, some of the aspects on the thermal breaches, we have to take this into account, because maybe if we fix everyone, we can have other problems in the future. So technical staff defining the solutions have to take all these aspects into account. If we look into the financial aspects, of course, maybe the first one and the one that appears into our minds is the high investment that has to be done. And I think that Ahmed and Paula will explain about this later in their presentation. This is, of course, an important barrier, especially for the external insulation solution, which usually has high cost, even more if the building is quite big. One thing that we have to take into account, both for the positive and for the negative part, is also the maintenance cost. Changing the elements on the building may lead to have different maintenance activities. And this can be higher or lower depending, but have to be taken into account in a long-term analysis of the economical aspects. And also be careful with the public funding. It's, of course, they help a lot into entering in this kind of actuations, but also we have to be careful with the taxation aspects. And finally, if we speak about the social and the legal aspects, some aspects that come out in these projects are some oppositions in some cases from the residents or from the owners, depending on the case, to be done. And once approved, some aspects that we can have problems with are the definition of the aesthetic aspects. Maybe not everyone agrees on what are the things that they want to have in their buildings from the outside. And of course, as I was mentioning before, and linked with the aspect that Anna was commenting before about the heritage buildings, of course, we have to check if there are heritage restrictions and other kind of permits that we have to ask to the local authorities. And finally, just to share with you before finishing this presentation and going into an interactive session, some good practices where you can find more examples apart from the ones that you will see in our own webpage of the SUPERSHINE project, which are those project Artus Cities and Remote Urban, which were doing similar interventions that the ones that we were speaking in this presentation, and some other initiatives like Build Up and IAA buildings, which you will find more information to broaden the information that you have been listening today. And that's all from next one. Yeah, that's all from our side. This is us. And if you have any question even further in the future, or even if you are a listener of this recording in the future, you can contact us to ask for more information. And thank you very much. And now I think that Anna will go to the, thank you, Ricardo,
yeah.
sorry.
No, it's correct. So thanks, Julia. Thanks, Anna. Yeah, I think, since, we are going a little bit longer, but, you can go straight to the interactive part.
Yeah, I will share the link in the chat as the previous way. Now I will share my screen with this new play game. I need to check if you can see my screen. Yeah. So
yeah, we can.
Okay, we can start. In this technical part, the first question is which intervention can reduce up to 30% of energy losses in an old building. You have 3 options, and you need to select what do you think is the correct. In that case, is the second one, applying an ethics external isolation system. The second one is what is the main technical challenge when you improving the building envelope of facade. This information we provide you during the first part of the technical webinar, and in that case is the second option, thermal condensation issues. The third one is in older buildings or which intervention typically reduce energy use by more than 20%. Obviously, a smart facade gadget is no action, is only a sensor. The painting of the facade don't improve any energy behavior in one building, so the correct answer is the second one. And the last question is which buildings should be prioritized in the envelope insulation work? And the correct answer is the first one. So congrats for all the participants, and I don't know if somebody have any question about this technical part, or
otherwise we can move to the next one if you consider.
Yeah.
Okay, I personally did it again, so good. No, pretty interesting. And what we see in this presentation is that, that of course the combination of intervention, it's possibly, if financially suitable, is of course one of the best possibility we have, not only to increase the performance of the building, but also to tackle the environmental issues like pollutions and health issue related to the citizens and people living in in the city or in the neighborhood we are working on. And so going through the environmental issues, so we skip to Circe and to Eva for her presentation. So Eva.
Okay, yeah, here I am. Let me share the presentation first. Okay, can you see, right? Yeah, I think so. It's already presented?
No, Eva.
No?
It's loading.
Yeah,
not there.
Yeah, okay, perfect then. So, well, thank you so much. In this case, let me My name is Eva Roldán from CIRCE, the Technical Center, the CIRCE. And in this case, I'm going to present an overview of the topic urban decarbonization, explaining a bit why it is essential to comply with the European goals and which technical solutions cities could deploy to accelerate their climate transition to neutrality. So in this case, why is decarbonization important? Well, urban decarbonization is a key pillar for meeting European climate commitments, as I said, due to the fact that the cities concentrate more than 50% of the population and therefore most of the energy demand and greenhouse gas emissions. And precisely for this reason, they have the highest potential for this transformation. So acting at the city scale can produce high benefits in efficiency, air quality, and citizen well-being. As you already know, I suppose, the European Commission has defined ambitious targets, like achieving 100 climate neutral cities by 2030, and extending this target to all European cities by 2050. So these goals should provide a common framework for establishing policies, funding instruments, and other technical activities. From a technical point of view, urban decarbonization requires a comprehensive and coordinated approach, looking at the city as a whole system. For cities to effectively reduce energy demands and greenhouse gas emissions, they need to improve their different aspects in general, like footprint of the construction materials of the different buildings and of the civil infrastructure, and, for instance, the deployment of clean energy system. But how to address this strategic axis, we can materialize it or driven it in a specific actions like a deep renovation of existing buildings, the deployment of efficient and grid interactive infrastructure, larger scale integration of renewable energy sources, or the promotion of zero emissions mobility across the city. So if we look a bit more in detail in one by one, regarding the deep renovation of existing stock buildings, it is one of the most effective decarbonization measures or actions, because by upgrading envelopes, HVAC systems, or installing renewable facilities, it's possible to significantly reduce energy demands while improving at the same time comfort and indoor quality of the dwellers. In case of, by deploying the grid interactive efficient buildings, they become or may become an interactive asset capable of adjusting consumption, integrating storage and shifting loads, providing at the same time system stability and facilitating higher penetration of renewable energies. When it comes to electrification or the electrification of end uses itself, it is a key enabler for phasing out the fossil fuels, because it allows building an urban system to rely on more clean energy or more clean electricity in this case, based on low carbon sources and renewable energy, if possible. And it's not for every cases, but in several climate contexts, and when it's possible, of course, because it's, for instance, a new design generally, the deployment of district heating and cooling networks, together with, of course, local renewable energy penetration or generation, can reduce district emission and provide an efficient collective energy solutions at the urban scale very conveniently. But of course, it's not for retrofitting or for all the cases or context. It has to be considered. And regarding the zero emissions in urban mobility, it should also be refocus or be transitioned to zero emission models based on electrified transportation modes, public and private as well, integrating digital solutions to optimize mobility flows and reduce congestions. But of course, all of these ideas of decarbonization are great, and all of this we already know. They are not news for us at all. The difficult part here is to know how to choose them effectively and implement them properly. I mean, for cities to deploy such an ambitious technical implementation in their different urban areas, it's necessary to follow specific preliminary phases or steps based on a structured framework to plan and select properly the most promising ones or technical measures before the real implementations. And the steps to be followed could be the following ones, more or less. The diagnosis and the target setup, the feasibility studies of the possible implementation to be done. In third place, the technical scoring of the implementations. And finally, of course, the implementation itself. But the main objective of these different steps is to ensure that the intervention or the implementation finally selected are technically solid or sound, economically viable, and obviously allows as well the cities to achieve their goals. So looking a bit one by one, when it comes to the first one, it should be focused on performing a complete diagnosis, first of all, the city, establishing the baselines of energy consumption and emissions, collecting the building's performance data, and then analyzing the different load profiles. And after that, based on the different results obtained from this analysis, the cities should define their own targets and plans and roadmaps, align, of course, with the European goals and the different requirements of the different directives in force, like the energy performance of buildings and the more general one, the energy efficient one. In the second step, considering the targets already established by the city in the previous stage, it must be focused on carrying out the techno-economic feasibility studies of the different interventions susceptible to be deployed to reach the different targets. For instance, building retrofitting, electrification of systems, deployment of renewable energies or storage or different stuff. And based on the result obtained of these feasibility studies, the cities should select the feasible ones and reject the rest. So in the next step, once the feasibility intervention has been selected for being the most profitable ones or the most viable ones, the city should evaluate this intervention as well using a scoring criteria, evaluating different aspects or KPIs, in a more multi-criteria point of view, including, for instance, energy saving potential, the emission reduction, cost effectiveness, replicability, social impact, or alignment with the European commitments or goals. So this scoring assessment should serve the cities to guide their decision-making process and to prioritize their investment, first of all, to select them. And finally, of course, the implementation phase should include the deployment itself of the specific technology strategies chosen for being the most promising one, the more feasible ones, and all of this, and to cover the objectives set up. But of course, it had to be well done, this intervention, because it's important to stick to a solid plan to ensure that the scoring results theoretically calculated in the previous step are still valid at the end of the project. Because, the costs can be higher than the expected ones if you don't address or you don't manage all the different actions properly. So, in addition to this, we have to also consider the risks. And it's important to see that or to acknowledge that urban projects face common risks like data gaps, regulatory barriers, budget constraints, or limited citizen engagement. And to address these challenges effectively, cities must take an integrated approaches, working closely with the stakeholders and basing their decision on reliable data, not just other projects previous or just general information for other places. So conversely, isolated actions or poorly evaluated investment should be avoided at all. Well, here, this slide shows a bit more or some recommendations obtained from previous urban projects. And in general, in terms of what should be done, it could be advisable to start with, first of all, with compact district or small districts where energy demand is more concentrated and the solutions are more cost effective. And it's also recommended to use standardized data models to improve the comparability and the scalability of the interventions to other areas. And early citizen participation is also essential to build trust, improve the quality design as well with their opinions, and increase social acceptance at the end. And in terms of what not to do, affordability should never be overlooked in this case because high cost will undermine social acceptance for sure. And besides, legal and regulatory constraints must be carefully evaluated and taken into account for the outset. And general approaches should be avoided as well. The approach should be a tailored one because in urban context, the building stock and the different governance structures vary considerably each other. So it has to be very, very focused on the specific area we have. And of course, it's worth mentioning that urban climate actions is not only something to be addressed technically, but it should also be based on other values like collaboration, citizen participation, and long-term governance to get a successful decarbonization. In fact, the cities that integrate effectively all of these values are the ones which get the more resilient and sustainable environments at the end. And just to finish, mention that municipalities also can rely on the already established tools, like the SECAPs for integrated energy and climate planning, SAMs for sustainable mobility strategies, energy efficiency contracts for performance or performance-based renovation, and one-stop shops models for guidance for guide the citizens or different owners through the renovation funding access. And this is the end of the presentation. Sorry for going a bit quick, but I think we will have a bit pressure for time. So
thank you very much, Eva. Thank you, really. And so we are almost in the schedule. And so okay, now we have the last speech of this workshop, and it's on our main result and main focus of the entire SUPERSHINE project, and I mean the financial solution and the financial possibilities in order to have the possibility to make the intervention in the neighborhood, of course, then have all the positive effect. And for doing this, I will leave the floor to our scientific coordinator, so the University of York team. So now Paula Ament, who is gonna lead this part.
Thank you, Ricardo. Thank you all the other colleagues for their very interesting presentations as well. So now we are going to talk about the financial solutions that we have been evaluating specifically for the SUPERSHINE Lighthouse districts, but also for the fellow cities. Ahmed, my colleague, is going to talk about the fellow cities particularly. I'm going to share my presentation. Just 1 second. Can you see?
Yes, it's perfect. Yeah.
Okay, thank you. So just to give you a flavor of what we have been doing is we have been studying financial solutions that allow the social housing and the affordable housing companies to share the risk of the investment and also the cost of the investment with some other institutions, for example, energy service companies. And we have been evaluating various contracts. What we are going to show you today are the best performing ones, okay? And we have been doing that in the light of reducing energy poverty across both the Lighthouse districts and the fellow cities. Okay, so let's go forward. Okay, so I will skip this because already my colleagues, they gave presentations, but now I'm going to talk about our Lighthouse districts in Denmark, in Italy, and in Latvia, and Amanda is going to talk about the others. Again, just to give you a little bit overview of what the type of investments that we have been considering for Denmark, we are talking about 79 apartments. The total cost of renovation is about 25 million euros, of which 20 million already they are covered by the available funding that is public funding, but still there is about 5,500,000 gap. The initial energy performance certificate we are starting from is about D, and the expected one after renovation is A. In Italy, we are talking about 128 apartments initially, but these are going to be knocked down and rebuilt, and the resulting ones, they are going to be 56. The reason why they are knocked down is they're going to be knocked down is that the renovation is not feasible for these ones, also because they don't meet safety criteria. But the current energy performance certificate is a level E or F, and the expected one is A2. Actually, for these buildings, when we started the project, we expected that the funding gap was about 11 million euros, but in the meanwhile, after we started the project, the regulation changed, and for this type of buildings, the funding needs to be all public. But actually, the analysis that we have done can be applied to other type of social housing buildings in Italy, so the ones that need renovation, not totally built. In Latvia is our biggest district, where we are talking the analysis that we have done is for 1,129 apartments whose initial energy performance certificate is a level E or F, and the expected one after the renovation, the energy efficiency refurbishment is A. For this case, we are talking about 11 million euros of funding gap after considering the funding, the public funding. But the public funding has a constraint that the energy savings, they need to be at least 30% coming from the refurbishment. But this is also the case for other countries, that in order to get public funding, they need to demonstrate that they are going to achieve a decent level of energy performance or energy efficiency after the renovation. So again, just a quick flavor, we have been considering either altogether or separately interventions on walls, on windows, on roof and floors. And we have been calculating the energy savings that are associated to this intervention for all the period of the investment, for all the cases. Again, were more or less, but this type of interventions, they've been discussed in detail, and also the ideas, they came also from our Lighthouse district, so a bottom-up approach. The reason why I'm mentioning that is that our financial analysis is based on the energy savings that are connected to each intervention. Again, just to give you an idea, considering the annual energy consumption per dwelling, if you look at the orange one, is the one that is currently for each country, and the blue one is the one expected after the energy efficiency renovation. As you can see, particularly for Latvia, where the starting point is much lower than in the other cases in terms of energy performance, the potential savings are massive. Again, we can also consider the mirror aspect of it in terms of potential annual energy savings per dwelling, both considering all interventions altogether or considering single interventions on wall, on windows, or roof and floor. Why are we considering all interventions all together? That, obviously they will make more sense because in terms of energy, of economies of scale, they will allow lots of financial savings compared to single interventions. The reason is that we have been asked by our Lighthouse districts also to consider single interventions because sometimes the entire intervention can be too disruptive for the tenants, or also can be too expensive to be done all at once. So that is why we have considered also the other ones, the single interventions as well. But as you can see, the potential energy savings, considering all interventions altogether, or even the single interventions, particularly on walls, they are very, very big. Okay, so just for most of our cases for our Lighthouse districts, the contract, again, a quick flavor that seems to be performing the best is called share saving contracts, where all the investment risk is taken by the ESCO, and also the maintenance and operating costs are faced by the ESCO. The ESCO, the energy service company, in case where the savings that are associated to the interventions are higher than the minimum guaranteed savings. Minimum guaranteed savings are the cost of debt that are associated to the investment. So if these energy savings are high enough, then they get they recover both the cost of debt, plus they get 65% of the extra savings. And in that case, the social or affordable housing company gets 35% of the extra savings. But if the energy savings are lower than the minimum guaranteed savings, the ESCO gets the energy savings, and the affordable or social housing company gets zero. why this is the case. The contract is designed for the ESCO to take all the investment risk, and that is why will get most of the savings in this case. But still, considering also the increased value of the building after the investment, still this type of investment is the best one also for the social or affordable housing company. And also in some cases is the only type of contract that can be applied, because again, since we started the project, we have been told that some companies, they cannot take by law the investment costs. The social housing companies, for example, the ones in Italy, they cannot take this risk anyway. But if we consider the return on investment of this type of energy efficiency interventions compared to a safe financial investment, so we consider the standard an investment on the Standard & Poor's 500 for the same period of the investment for these buildings. You see that considering all the interventions, this return on investment is for Denmark is a very good investment for both the affordable housing company and ESCO. And even considering the single interventions, it is still the return on investment is still very good, apart from the case for the windows, because obviously the energy savings that are associated to window replacement are lower. But as I said at the beginning, normally the rule or the constraint for this type of interventions in order to get some public funding is that they need to pair at least a couple of this type of investment, for example, wall and roof, or roof and floor, or whatever, to reach at least something like 30% of energy savings. So that is why in all the cases, this type of investment is, even from a financial point of view, not just considering the the impact on the environment, the impact of energy poverty is very good for all the parties. And the same is true for Italy, for Boito. Again, we'll be sharing our slides so you can have more details, and also actually we'll be putting some details, financial details about this type of investment on our websites in the next couple of weeks. And the same is true for Riga. Okay, so again, just considering from a financial point of view, these investments are very good because they are always higher than kind of a safe financial investment on the Standard & Poor's 500. If we consider the impact on energy poverty, so considering, for example, one of the main indicators of looking at energy expenditure as a percentage of income, so we see that this expenditure goes down a lot. So the blue one is the expenditure after the energy efficiency renovation. It goes down massively, particularly for Latvia and for Italy. For Denmark, it goes down, but at a lower rate, because obviously the starting point, the energy efficiency starting point for Denmark is much better compared to the other two cases. So again, if we consider another main indicator of energy poverty, so the percentage of residents unable to keep their houses cool in the summer and warm in the winter. Again, this percentage of people that are affected by energy poverty goes down massively, particularly in Italy and also in Latvia, but also in Denmark. So, before we looked at the financial point of view. Here, at the beginning, we looked at the potential energy savings that also they can be considered as a lower impact on the environment. Here, we are considering the impact of energy poverty. And last one, energy consumption, again, for all the cases, it goes down massively for Italy, for Latvia, and also for Denmark, for all the cases. So that was me. Now I leave the floor to my colleague Ahmed Jeddi. Dr. Ahmed Jeddi is going to talk about the analysis for the fellow cities. Thank you.
Thank you, Paula. Just share my screen. Sorry. Can you see my screen? Hello?
Yes, Ahmed, go ahead, please. Thank you.
Okay. So, yes, I will try to go a bit fast to don't have enough time. Okay, so we sorry, these are the sorry, yeah. Yeah. So as part of the SUPERSHINE project, we also conducted financial and energy poverty analysis for the fellow cities, which are Portugal, Spain, Serbia, and in Turkey. So in Portugal, the building stock is 25 houses with EPC level F, and after the renovations, it is expected to go to level A, and the total investment cost is 422,000. In Spain, the housing stock consists of 2 buildings with 288 apartments and EPC level C, and after the renovation, it is expected to go to level A, and the total cost is a little over 5 million euros. For Serbia, the housing stock consists of several buildings containing over 1,200 apartments with EPC level E, and it is expected to go to level A with total cost approximately close to 1.5 million euros. And in Turkey, the housing stock is 17 buildings with EPC between E and F, and it is expected to go to level A, and the total cost is over 7.2 million euros. So for the Cibutal case study, we observed that the shared saving contract is the most suitable contract for implementing the EE renovations, and the expected return on investment under this contract is 12.03% for social housing and 10.13% for the ESCO when we consider all the interventions together. And as you can see, it is a very promising investment, as it provides a significantly higher return on investment than investing in the benchmark S&P 500 index. Also, we did the analysis on each single intervention by itself, and we observed a similar conclusion that the return on investments for the wall, roof, and the floors are higher than investing in S&P 500, except for the windows. For Portugal, we observed that the shared saving is also considered the most suitable contract, and under this contract, the return on investment is is higher than 14% for the social housing and the ESCO when all interventions are considered, which is also significantly higher than investing in S&P 500, which is also the case for each single interventions except the windows. Yes. Also here we have we present the guaranteed saving contract. So under this contract, the social housing organization is responsible for covering the investment cost, and if the energy savings are higher than the minimum guaranteed savings, they receive the minimum guaranteed saving plus 20% of the difference between the energy saving and the minimum guaranteed savings. And if the energy savings are lower than the minimum guaranteed savings, the social housing gets the minimum guaranteed savings. Also, they benefit from the increased value of the building. For the ESCO, if the energy savings is higher than the minimum guaranteed saving, they get the 80% of the difference between the energy savings and the minimum guaranteed savings. Also, in the case where the energy savings are less than the minimum guaranteed savings, then the ESCO is responsible for covering the minimum guaranteed savings to the social housing. Under this contract, the ESCO is responsible for the maintenance and operating costs of running and the energy efficiency technologies. Okay, so for Serbia, we observed that the guaranteed savings is the most suitable contract with expected return on investment for social housing and the ESCO being 11.4 and 9.6%, which is higher than the S&P 500. Okay. So we observe the same for Turkey.
Ahmed, it's the same for each one of the towns that you have been, or the fellow cities that you have been analyzing. Perhaps it would be more interesting to look at the energy poverty indicators now.
Okay, so for the energy poverty indicators, we considered 3 indicators. The first one is the energy expenditure as a percentage of income. And as you can see, there is a significant improvement in this indicator after when the AA renovations are implemented, with Turkey having the highest improvement. For the second energy poverty indicator, which is the percentage of residents unable to keep their houses cool in the summer and warm in the winter, we observe also significant improvement in all the fellow cities of approximately 40% improvement. For the third energy poverty indicator, the energy consumption in kilowatt hour per square meter, we also observe significant improvement, with Turkey and Serbia experiencing the most improvement. Yeah, so that's it for us. Thank you a lot. I tried to finish in time.
No worry.
Thank you.
Thank you, Ahmed.
Thank you, Paula. Thank you very much. And thank you to all the other speakers and to those who attend the meeting until the end. Okay, no problem. So that there is a registration of this workshop. So there's going to be the possibility in the future to watch it again, or to watch it for the first time, and to get in contact with the consortium of SUPERSHINE for going much deeper in all the topic we face today. So I would like to thank you all once again, and to close the workshop. And yeah, stay tuned for the future results of the SUPERSHINE project, and thanks for sharing contents on the chat. We will we're going through it very carefully. Thank you. Have a nice day.
Thank you, guys. Bye.
Thank you.
Thank you.
Bye-bye.
Bye, guys.
Bye.
Bye.
Bye bye. Thank you.